So if you have something like b to the power of x is equal to n, then you can turn this into log base b of n is equal to x. For example, if you have 2 to the power of x equals 16, and you're trying to find x, you can turn this into log base 2. This number is the base of 16 is equal to x. And this is useful if you have something like this, where you're trying to find x and you can't just like guess and check, because you just like do like 2 to the power of 2 equals 4, or like 2 to the power of 3 equals 8. But this makes it as a function that you can put into your calculator, so you can just figure it out very easily. So for example, if you have something like this, where 3 to the power of x is equal to 81, and you have to find x, instead of just guessing and checking for x, you can just turn it into this log base 3, because this is the first number, of 81 is equal to x. And if you put this into your calculator, you get x is equal to 4. So this is a much easier way to find the value of an exponent, but when you're given like the other two values. And also, if you have a logarithmic equation or expression that doesn't have a base, that means the base is 10, because that's the default. So if you have log 100 with no written base, this means this is equal to log base 10 of 100, which is just 2. There are also some laws in logarithms, such as if you have log base c of a times b, this is equal to log base c of a plus log base c of b. So you can split this a times b into two of them, but also if you have two of these, two logarithms with the same base, you can combine them, turn it into this. And another rule that you can do is if you have log base c of a over b, this is also equal to log base c of a minus log base c of b. And it's also like the same uses as above. If you have a fraction in a logarithm, you can expand it out into two different things, but also if you have two logarithms with the same base and you're subtracting one from another, then you can combine them into one. And also, if you have log base c of a to the power x, then this can be turned into x multiplied by log base c of a. And this is very useful because it gets rid of the exponent, and that's usually kind of hard to deal with when c and x are different. But there's another rule where if you have log base b of a, then this can be turned into log base c of a over log base c of b. And the good part about this is that c can be anything. You can set c to any number that you want as long as it's not 1. So if you have b as like 4, you can set c to 3, 5, 6, 2, whatever you want, as long as they're equal in the top and bottom. And the reason that the change of base formula can be so useful in some cases is that if you have something like this where you're trying to find log base 3 of 12, the number won't be a whole number because 3 to the power of 2 is equal to 9, and 3 to the power of 3 is equal to 27, and 12 is in between that. So you need to find out like a decimal. And also, some calculators don't allow you to put a custom base. A lot of calculators just like force you to stay in the default, which is base 10. So we can change this into log base 10 of 12 over log 3. And now, for a lot of calculators, it now allows you to put this into your calculator, and you get 1.08 over 0.48 approximately. This is around 2.25. And this number is not something that you could get just by trying to put this into your calculator, because a lot of scientific calculators do not allow you to put base 3 into the log. But using the change of base, we now are able to put this into our calculator and get a decimal value. Now let's do another practice problem. This one's pretty simple. It says to simplify log base 10 of 16 plus 2 times log of 3. And for this, we just use the rules that we talked about. First, we convert 2 log 3 into log 3 to the power of 2 and add log 16 to it. And then we just put this 3 to the power of 2, which is 9, so log of 9. And we use the rule to combine 2 logs of the same base that we're adding together, and this turns into log 16 times 9, and this is equal to log 144. It's pretty simple. So we just use two rules, the exponent rule as I like to call it, and the product rule or addition rule, whatever you want to call it. But these are pretty simple rules to use and understand, and that's how we got our answer. Now let's do our third practice problem. This one says to find x if log base 2 of x is equal to -3. And this one may be a little confusing at first because how do you find x if it's inside the log? Well, as we discussed before, you can just turn this into 2 to the power of -3 is equal to x. As I said, don't be scared to turn a log into an exponent form. And 2 to the power of -3 is just 1 over 8. So x equals 1 over 8. And this works if you have anything like log base 3 of x is equal to 2. Then you can just use the same logic. 3 to the power of 2 is equal to x, and x equals to 9. If you're missing the thing in the middle, but you have the other two values, you can always just convert it into exponent form and find the answer there easily. And now let's just do one last problem. This one says if a equals log base 5 of 2 and b is equal to log base 5 of 3, write log base 5 of 36 in terms of a and b. So what I first noticed here is that log base 5 of 36, well 36 is just equal to 2 to the power of 2 multiplied by 3 to the power of 2, because 36 is 4 times 9, and 4 is 2 to the power of 2, and 9 is 3 to the power of 2. Now we successfully divided 36 into terms of 2 and 3, which is what a and b are, log base 5 of 2 and log base 5 of 3. And now we can use the rule to separate this into log base 5 of 2 to the power of 2 plus log base 5 of 3 to the power of 2. We can now use the exponent rule on both of these to put the 2's into the front. So this is equal to 2 log base 5 of 2 plus 2 times log base 5 of 3. And now you can notice that we now have a and b in the equation. Log base 5 of 2 is right here, and log base 5 of 3 is right here. So this is just equal to 2a plus 2b. And when you have this type of problem, where you're given a and b like this, and you're given a more complex expression, and you're supposed to write it in terms of a and b, try to find something like I did here, where you find the middle term, such that you can write it in like using only these numbers, like 2, 3, like I did here, 2 to the power of 2 and 3 to the power of 2. If you do like log 5 of 12 times 3, that wouldn't really work, because although 12 can be written as 3 times 2 times 2, it's much easier to do something like this where you just have the square root of both values. So everything that I explained in this video and all the problems that I went through should teach you everything that you need to know the basics of logarithms. If you still don't fully understand this, then I would suggest rewatching the video or trying some practice problems like searching stuff online or coming up with them by yourself. If you learned something from this video, or if you enjoyed it, then please consider liking or subscribing.